Good morning. Today we are going to be handling Faraday's law of electrolysis. The first law states that the mass of a substance deposited is directly proportional to the quantity of charge. That is, M is directional to Q. And we all know that quantity of charge is equal to current times time, which is usually measured in coulomb. So say M is IT, and M now will be equals to ZIT, where M is equal to mass, and Z is equal to electrolytic constant, and I is current, then T is time. Now the second law states that the amount of element deposited in moles is inversely proportional to the charge it carries. So what they are trying to tell us is that the amount of substance deposited, which is N, is directional to the charge it carries. Now this one is equal to N equals to K over Z, where K is a constant. So what they are trying to say that where K is a constant. Oh, let's maintain our Q for charge. So where K is a constant. So K now will be equals to NQ. And if that is the case, then we can now say that N1 Q1 is equal to N2 Q2. Now, àlàyé ìkejì yẹn ni pé ìtumọ̀ ẹ̀ ni pé now gbogbo àwọn substance tó jẹ́ pé a máa ń discharge during electrolysis yẹn, be it all these basically metals or transition elements, and gbogbo charge tó ń gbé lórí yẹn òun ló máa ń determine iye bí a ṣe máa discharge ẹ̀. Take for example báyìí, tó bá yẹ pé copper ni, copper is always copper is always Cu2+. Ìtumọ̀ ẹ̀ ni pé charge tó wà lórí copper is 2. So tá bá máa sọ báyẹn, a sọ pé 2 Faraday of copper, 2 Faraday will deposit 1 mole of copper. Bó bá yẹ pé aluminium nísìn, charge tó wà lórí ẹ̀ is 3+. So you can say that 3 Faraday will deposit 1 mole of aluminium. So ìyẹn ṣe iṣẹ́ tí mo wá ṣe fún yín lénìí náà. You read through on laws of Faraday, Faraday law of electrolysis. But today, basically, the purpose of the video is to solve calculations on Faraday's law of electrolysis. So let's start. Now look at the first question. They say that during the electrolysis of silver nitrate 5 solution, 9,650 coulombs of electricity was passed. Calculate 1. The amount of silver deposited in moles. 2. The mass of silver deposited in gram. Then they say that 1 Faraday is equal to 96,500, and silver is 108 gram per mole. Now ẹ jẹ́ ká wo bá ṣe máa ṣe báyìí. Now, during the electrolysis of silver nitrate 5 solution, now they say that the amount in silver. Now, this one in this situation, this is AgNO3. There is the electrolysis. And looking from this solution, it is silver that will be deposited in a transition metal. So Ag, it will require Ag plus E minus to get Ag. Now, if you look at silver is carrying 1 charge. It will require 1 electron to change it to silver atom. So in this situation, if I want to make calculation, I will just say 1 Faraday will deposit 1 mole of silver. And we all know that 1 mole of silver, the mass in 1 mole of silver is the same thing as the molar mass. So I can just say that 1 Faraday, which is also 96,500 coulomb, will deposit 108 gram of silver. Now, in that case, if we have 108 grams of silver, then and based on what we have in the question, they say we use 9,650 coulombs. So that means if 96,500 coulomb will deposit 108 grams of silver, which is equivalent to 1 mole of silver, then 9650 coulomb will deposit X gram, because we don't know the mass of silver deposited. We don't know the mass of silver, the amount of silver deposited in moles. Now let's quickly see what we can just do. What we just do here is this. It's very simple. Now, all we just need to do is to say, okay, we cross multiply this. We just properly we give it in proportion. 9,600 coulomb over 9,650 equals to 108 over x. So if we cross multiply this, we are going to have x to be equal to 9,650 times 108 all over 9,650. So if you cancel this one is going, then if I cancel this one will be 10. So the amount in grams is this is the mass of silver that is being deposited. Now let's see whether we can get the amount of silver deposited. Since this is the mass of silver deposited, let's see whether we can solve the number of moles of silver that will be deposited. Now let's quickly find out. So we need to find the number of moles. Let's find the number of moles now. You know that moles is equal to mass over molar mass. So the mass of silver deposited is 10.8 and the molar mass is 108. So therefore the number of moles there is 0.1 moles of silver. I believe that example is clear enough. Let's go for the example 2. Now, when a solution of copper 2 salt is electrolyzed, 3.2 gram of copper was deposited. Calculate the quantity of electricity required for the electrolysis. Now, let's look for this one now. This is a copper 2 plus that is being deposited. So this copper 2 plus, it will require 2 electrons before it can become a copper. Now, from this statement, it means that 2 Faraday will deposit 1 mole of copper. Now I told you earlier that the charge will determine the number of Faraday. So tó wáyé jẹ́ pé Cu2 plus ní 2 Faraday náà la máa lò. Now ẹ ká wo nǹkan tó máa ṣẹlẹ̀ sí. 2 Faraday will be equals to 2 times, because 1 Faraday is 96500. 2 times 96500 we deposit. What's the mass of copper? The mass of copper for 1 mole is 64 grams of copper. So the mass of 1 mole copper is equivalent to 64 grams. Now let's quickly do this. This one will now be 193,000, and we deposit. We don't know the mass of copper, so S gram of copper. Now let's quickly do the proportion. So 64 grams of copper first. Now they say that 33.2 grams of copper. We don't know the number of Faraday that will be able to do that. So let's now say X Faraday will deposit 3.2 grams of copper. So let's quickly find that one out. So you just have 193,000 over X is equal to 64 over 3.2. Now, this one will now be X equals to 193,000 times 3.2 over 64. If if I use this one to cut, we are going to have 20. This one is cutting this, and we can get this one now to be 9650. So this 9650 coulomb of copper that will be needed. I hope you found this video so helpful. We are going to do more calculations in due course, but firstly, this one will be like calculations on Faraday law of electrolysis. So though I've not been able to state the law in an extensive way because the video is based on the calculation. Thank you so much. Subscribe to our channel, and God bless you.